Good afternoon. I am Trisha Bimal Thakkar from grade 12, and today I'll be talking about artificial intelligence and machine learning. So, what is artificial intelligence? Artificial intelligence, or commonly known as AI, it is the ability for a computer to think, learn, and stimulate human mental processes such as perceiving, reasoning, and learning. It can also independently perform complex tasks that once required human input. On its own or combined with other technologies, AI can perform tasks that would otherwise require human intelligence or intervention. Digital assistants, GPS guidance, autonomous vehicles, or generative AI tools are just a few examples of AI that we use in our daily lives. As a field of computer science, artificial intelligence encompasses machine learning and deep learning. These disciplines involve the development of different AI algorithms modeled after the decision making processes of the human brain that can learn from available data and make it more accurate. Artificial intelligence has gone through many cycles of hype. There was the release of ChatGPT, which marked the turning point of AI, and it is widely used now. So, what is the historical context of AI? In 1950, Alan Turing proposed the Turing test, and this defined machine intelligence. And later in 1956, the term artificial intelligence was coined in the Dartmouth Conference, and this specific conference was marked the start of AI. And now the development phases of AI in 1960s to 70s, the focus was on rule-based systems, and there were different early AI programs such as ELIZA. Later, in 1980s and 1990s, there was a decline in AI interest due to unmet expectations, but soon this was followed by a resurgence where machine learning and AI bloomed. The key concepts of AI. So, shown here are the main concepts of AI. We have machine learning, neural networks, natural language processing, computer vision, reinforcement learning, and ethical AI. And now I'll be explaining how machine learning relates to AI. Although the term artificial intelligence and machine learning are frequently interchangeable, machine learning is actually a subset of AI. AI is a vast topic, and machine learning is just a part of AI. AI signifies the computer's general ability to mimic human thought, whereas machine learning implies to the technologies and algorithms, which allow the systems to recognize different patterns, make decisions, and improve themselves. So, what exactly is machine learning? It is a subset of AI, as I mentioned before. It focuses on the development of different algorithms and different models. This enables the computer to learn from and make predictions based on the data provided. It is a key driver of AI applications, and this includes natural language processing, image recognition, and recommendation systems. So, what are the different types of machine learning? We have three major types of machine learning, which is supervised learning, unsupervised learning, and reinforcement learning. I will be explaining each one of these in detail now. First, we have supervised learning. Supervised learning is defined as when a model gets trained on a labeled dataset. Labeled datasets have both input and output parameters. In supervised learning, Algorithms learn to map points between these input and the correct outputs. It has both training and validation datasets labeled. There are two main categories of supervised learning. These are classification and regression. So, what is classification? Classification deals with predicting categorical target variables, and these represent discrete classes or labels. So, for example, classifying emails as spam or not spam, predicting whether a patient has a high risk of heart disease, all of these are examples of classification. It looks at previous data and classifies the new data into different sets. It learns to map the input features onto one of the predefined classes. Some classification algorithms are the logistic regression, support vector machine, random forest, decision tree, and KNN. Regression. Regression, on the other hand, it deals with predicting continuous target variables, and these represent numerical values. So, for example, this predicts the house of a new house based on its location, its size, or it forecasts different sales of a product. Regression algorithm learns to map the input features onto a continuous numerical value. Some examples of this are linear regression, polynomial regression, ridge regression, lasso regression, the decision tree again, and random forests. So over here, regression, it checks the previous data and predicts new outputs, whereas the previous one checks the data and classifies it into different sets. So what are the advantages of supervised learning? So supervised learning models, they have high accuracy as they are based on labeled data previously mentioned. The process of decision making in supervised learning models is often very predictable and interpretable. It can often be used in pre-trained models, which saves time and resources when developing new models from scratch. Whereas it has several disadvantages too. It has limitations in knowing the patterns, and it may struggle with unseen or unexpected patterns that are not mentioned in the training data. It can be time consuming and costly as it relies on label data only, and it may lead to poor generalizations based on the new data if it's not specific enough. Now, what are the applications of supervised learning? It is used in image classification, natural language processing, speech recognition, which converts spoken language into text. It is used for recommending systems. This makes personalized recommendations to the users. It is used for predictive analytics. It is used for medical diagnosis. It can also be used for fraud detection. It's also used for email spam detection and quality control in manufacturing. So basically, all of this is related to a predefined data set, and it's either making predictions or it is classifying it into different sets. Next, I'll be talking about the unsupervised learning models. Unsupervised learning, it is a type of machine learning technique in which an algorithm discovers patterns and relationships using unlabeled data. Unlike the supervised learning, this does not involve providing an algorithm with labeled target outputs. And the primary goal of unsupervised learning is often to discover the hidden patterns, similarities, or clusters within the data, which can be used for various purposes, such as data exploration, visualization, etc. This also has two main categories, and it is classified as clustering and association. Clustering. This is the process of grouping data points into clusters based on their similarity. This technique is useful for identifying patterns and relationships in data without the need for labeled examples. A few clustering algorithms would be k-means clustering algorithm, mean shift algorithm, the DB-SCAN algorithm, principal component analysis, and independent component analysis. So over here, it checks the data and clusters them based on their similarity and not based on predefined data. Association. Association rule learning. It is a technique of discovering relationships between items in a dataset. It identifies the rules and it indicates the presence of one item implies the presence of another item with a specific probability. And so now the examples of this would be a priori algorithm, ECLAT, FP growth algorithm, etc. The advantages of this would be it helps to discover hidden patterns and various relationships between the data. It's used for tasks such as customer segmentation, anomaly detection, and data exploration. It does not require labeled data, and so this reduces the effort of data labeling. This also has its own disadvantages. Without using labels, it may be difficult to predict the quality of the model's output. It could show incorrect outputs at times. Cluster interpretability may not be clear, and it may not have meaningful interpretations. It has techniques such as autoencoders, and this can be used to extract meaningful features from raw data. And now the applications of unsupervised learning include market basket analysis, genomic data analysis, image segmentation, community detection in social networks, customer behavior analysis. Over here, it uncovers patterns and insights for better marketing and better product recommendations, content recommendation, and anomaly detection. So over here, it checks the data and it makes different predictions. In content recommendation, it classifies and tags content to make it easier to recommend similar items to users. And the last type of machine learning is reinforcement machine learning. Reinforcement machine learning algorithm is a learning method which interacts with the environment by providing actions and discovering errors. Trial, error, and delay are the most relevant characteristics of reinforcement learning. In this technique, the model keeps on increasing its performance using reward feedback to learn the behavior or the pattern. Each time we feed in data, they learn and they add their data to this knowledge, which is the training data. So the more it learns, the better it gets trained and hence experienced. The two main types of reinforcement machine language are positive and negative reinforcement. Positive reinforcement. This rewards the agent for taking a desired action. It encourages the agent to repeat this behavior. So, for example, giving a treat to a dog for sitting, or providing a point in a game for a correct answer. This is an example of positive reinforcement. Negative reinforcement is the opposite. It removes an undesirable stimulus to encourage a desired behavior. And this discourages the agent from repeating the negative behavior. So this example would be turning off a loud buzzer when a lever is pressed, or avoiding a penalty by completing a task. Here we are avoiding the undesirable stimulus and it discourages the agent from repeating this behavior. What are the advantages of reinforcement learning? It has autonomous decision making that is well suited for tasks, and it can learn to make a sequence of decisions, like robotics and game playing. This technique is preferred to the achieve long-term results that are very difficult to achieve. So it helps us get long-term results. It does not require label data and reduces the effort of data labeling. But the disadvantages of this would be it can be expensive and it can be time consuming. Reinforcement learning is not preferable when it comes to solving simple problems, because if the problem is simple, we can use either of the two types mentioned before. This is only used for the complex problems. It needs a lot of data and a lot of computation, which makes it impractical and costly. Now, keep in mind that reinforcement learning is a very complex algorithm and it's only used occasionally because it is costly and it's impractical to use it for solving simple problems. What are the applications? It is used in game playing. It is used in robotics. It can teach the robots to perform tasks autonomously. It is used in autonomous vehicles. This includes different self-driving cars or navigation system in cars that are used to make the decisions. It is used in recommendation systems. It can enhance the recommendation algorithms in different websites or applications according to the user preferences. It is used in healthcare. It is also used in NLP, which is natural language processing. It is used in finance and trading. And an important application here is virtual reality and augmented reality. It is used to create an immersive and interactive experience for the users. Now, I'll be talking about what models are. A machine learning model is a type of mathematical model that, after being trained on a given subset, on a given data set, can be used to make predictions or classifications on the new data. During training of a dataset, a learning algorithm adjusts the model's internal parameters to minimize the errors in its predictions. By extension, the term model can refer to several levels of specificity, from a general class of models and their associated learning algorithms to a fully trained model with all of its internal parameters tuned. Models itself has types of its own. The different types of models are artificial neural networks, decision trees, support vector machines, Bayesian networks, regression analysis, and Gaussian processes. Over here, I'll be discussing the artificial neural networks and decision trees. Artificial neural network. An artificial neural network is an interconnected group of nodes which are very similar to the network of neurons present in our brain. Here, each circular node over here, this represents an artificial neuron, and the arrow represents a connection from the output of one artificial neuron to the input of the other. In the given figure, we have input, hidden, and output. Over here, the circular node is the neuron, and it connects the output of input to the hidden, and the output of hidden is sent to the output as input. Decision tree. Decision tree learning uses a decision tree as a predictive model to go from observations about an item, which are represented as the branches, to conclusions about the item's target value, which are represented in the leaves. It is one of the predictive modeling approaches that are used in statistics, data mining, and machine learning. In the figure over here, we have the leaves and we have the different branches. What are the roles of data in machine learning? It has various roles in machine learning. It trains machine learning models. it is used for training the machine learning models. This means that data is very important as we ourselves are training different models in machine learning to give us different predictions or different classifications. Testing and evaluation, data augmentation, and anomaly detection. Ethical considerations. As AI is increasing daily, everyone is using AI, but we need to make sure that we use it properly and we don't exploit AI. So, how do we do that? Bias and fairness. AI systems can inherit biases from their training data, and this could result in unfair or discriminatory outcomes. Ethical AI requires addressing and mitigating bias to ensure that all AI systems are fair and equitable for all individuals and groups. So we should make sure to avoid bias and there should be fairness in the AI systems. Data protection. AI often relies on large data sets. This raises concern about data privacy. Ethical AI, it practices ethical AI practices involves protecting the individual's data and ensuring that there's transparency about how the data is collected, used, and stored. So this avoids any issues related to someone's data getting hacked or leaked. Autonomy and control. Ethical AI considers the degree of autonomy given to AI systems and the control mechanisms in place. Maintaining human oversight and control is important in critical decision-making processes. Preparing AI for the future. Preparing for the future with artificial intelligence involves strategic thinking adaptability and a focus on harnessing the potential of AI to drive innovation and address societal challenges. Here are the key steps and considerations for preparing the future with AI. Education and skills development. As we know, AI plays a huge part in the education sector right now. Students use AI for research, to learn more, to help with their homework, and so do the teachers for gaining a better perspective on how to teach the class. Data management and security, ethical and responsible AI integration and talent, innovation and culture. As we all know, this has played a huge impact on all of our lives. And so we should prepare for the future. Keep in mind that we should use ethical AI. There should not be any discrepancies and there should not be any harm from AI. Thank you, and I hope you have a nice day ahead.